Elasticity is related to revenue in a special way. Let's take a look at the revenue function based on price and quantity. So revenue is equal to the price per product times the number or the quantity of the products sold. And if we wanted to take the derivative of the revenue with respect to price, we would need to use something called implicit differentiation. Now, we haven't really talked about implicit differentiation, so just try your best to follow along. But we have a function that has two variables, so we're going to need to use the product rule, and we're taking the derivative with respect to p. So we're going to have first times the derivative of the second, plus the second times the derivative of the first, which is 1. So I'm just going to rewrite this as p times dq dp plus q. And I'm going to just do this weird thing where I multiply this by q over q. And I can do that because q over q is 1. And I'm just going to rewrite this a little bit differently. So dr dp is equal to q times p over q times dq dp plus q. Now, this thing here should look kind of familiar, and it's almost exactly the value of eta, but it's missing a negative sign. And so this thing here, it is the same as negative eta. So we get dr dp is equal to q times negative eta plus q. And notice that both of these terms have a q in it, so I can factor out a q, and I get negative eta plus 1. Or if I rewrote that, or I reordered that, I'd get that it's equal to q times 1 minus eta. Okay, so what does that mean for when we have elastic, inelastic, and unitary elastic? Let's take a look below. So when we're talking about the quantity of a product, this value here has to be greater than 0 or equal to 0, greater than or equal to 0. So if the product that we're looking at is elastic, that means eta is going to be greater than 1. And so if this number here is greater than 1, if that number here is greater than 1, then dr dp is going to be negative. That means that if price increases, revenue decreases, and if price decreases, revenue increases. So in scenarios of inelasticity, eta is less than 1, and so that means that dr dp is going to be positive, which means that if prices increase, then revenue increases, and if prices decrease, then revenue decreases. The last scenario is if eta is equal to 1, which means that our dr dp is going to equal 0, and that means that an increase or decrease in price will not change revenue. Revenue is optimized at this point. Let's look at an example. Example 2 says find the elasticity of demand function PQ equals 81 at P equals 3. How will a price increase affect total revenue? So we want to find eta, which is equal to negative P over Q times dq dp. And so we need to take this function and we need to solve it for Q. So if we did that, we get Q equals 81 over P. And then if we take the derivative of that, we get negative 81 over P squared. Okay, and when P equals 3, so if we get Q equals 81 over 3, which is equal to 27. So if we're filling in these values here, then P is going to equal 3, Q is going to equal 27, and then we need to also evaluate dq dp for when P is equal to 3. So that's going to be equal to negative 81 over P squared, which is 9. I guess let me write it like this. So that becomes negative 81 over 9, which becomes negative 9. So this drops down there. dq dp evaluated for when p equals 3 is negative 9. And then if we simplify that, that ends up being 1. So the second part of the question asks, how will a price increase affect total revenue? Let's remind ourselves from that chart up above. So we have the third scenario where eta is equal to 1, and that means an increase or decrease in price will not change the revenue. So we'll say a price increase will not change revenue. Example 3 says, find the elasticity of demand function p squared plus 2p plus q equals 49 at p equals 6. How will a price increase affect total revenue? So just like last time, I'm going to take this and I'm going to solve it for q. And if you solve it for q, you get negative p squared minus 2p plus 49. And then if we took the derivative of that, we would get negative 2p minus 2. Okay, and we want to evaluate that for when p equals 6, because we have p equals 6 right here. So that's going to be negative 2 times 6 minus 2, which is equal to negative 12 minus 2, which is equal to negative 14. So eta is equal to negative p over q times dq over dp. And let's see, negative 6 over, so here we need to plug in p equals 6. So we get q is equal to negative 6 squared minus 2 times 6 plus 49. And that's going to be negative 36 minus 12 plus 49, which equals 1. So I'll have negative 6 over 1 times negative 14, and that is going to equal 84. 84 is greater than 1, so looking back at our chart, this is an elastic scenario. So I'm just going to box my answer here. We got eta is equal to 84, and that means we have elastic, and so a price increase means that leads to decrease in revenue.